In this example, we're asked to consider the velocity of an object moving along a line shown in the figure below. And we need to use geometry to find the displacement of the object between t equals 0 and t equals 2. So we see that the traditional y-axis for the graph below is the velocity axis. So this is our v-axis, and our velocity is in meters per second. The traditional x-axis is our t-axis, which is time, and our time is in seconds. So to find the displacement, we just need to find the area beneath the curve from t equals 0 to t equals 2. And we know that when we find the displacement, it's going to be in meters per second times seconds, which will give us meters. But let's first take a look at the graph and kind of analyze it so we can figure out what's going on here. Because this is the graph of the velocity of an object, we can see that the velocity is increasing between t equals 0 and t equals 1, because between t equals 0 and t equals 1, our graph is increasing. So that means that the velocity is steadily increasing on that interval. On the interval from 1 to 5, we see that the graph of the function is constant. So that means the velocity is constant on the interval from 1 to 5. On the interval from 5 to 8, our graph is decreasing, so the velocity is decreasing. And then from 8 to 10 and beyond 10, our graph is constant, so the velocity is constant. Now let's see if we can find the displacement between t equals 0 and t equals 2. That would be equivalent to finding the area of this shape. This is a trapezoid because we have two sides that are parallel, so we would use the formula for the area of the trapezoid. The height of a trapezoid is just the distance between the two parallel sides. And b sub 1 and b sub 2 are just the length of the bases. Well, that's the length of each parallel side. The two parallel sides are here and here. The distance between those two parallel sides, which is the height, is 20. The length of the lower base is 2, and the length of the upper base is 1. And now all we have to do is simplify this expression. So the displacement is 30 meters on the interval from 0 to 2. In the second part, we're asked to use geometry to find the displacement between 2 and 8. That's equivalent to finding the area of this shape. That shape can be divided into two geometric figures, a rectangle and a trapezoid. Let's find the area of the rectangle first. The base of the rectangle is 3 units and the height is 20 units. So the area of that rectangle is 3 times 20, which is 60 meters. Now let's find the area of the trapezoid. The two parallel sides are the two bases, and the distance between those two parallel sides is the height. So our height goes from 5 to 8, which means the height is 3. And the bases have lengths of 20 and 10 respectively. 20 plus 10 is 30, so we have 1/2 times 3 times 30, which is 45 meters. Now to get the total displacement of the object between 2 and 8, we add the displacement between 2 and 5, the area of the rectangle, to the displacement between 5 and 8, the area of the trapezoid. So the total area or displacement is 105 meters. The last part's a little bit trickier. We're asked to assume the velocity remains 10 meters per second for t greater than or equal to 8. And we're asked, what is the displacement function between t equals 0 and any time t is greater than or equal to 8? There are a couple things that we need to do to come up with this function. The first thing we need to do is come up with an expression that will represent the area under the curve from 8 on. So in other words, we need to come up with an expression that will represent this area and beyond. The good news is that the velocity remains constant for any t greater than or equal to 8. It remains constant at 10. So to find the formula for this, we're going to use the formula for a rectangle. The height of that rectangle, no matter how far we extend on the t-axis, will always be 10. So we have base times 10. Now we need to come up with an expression to represent the length of our base. To do that, let's just look at the length of the base for the shaded area that we have here from when t equals 8 to t equals 11. For this shaded area, the base has a length of 3 because 11 minus 8 is 3. For this shaded region, the base would be a length of 2 because 10 minus 8 is 2. And for this one, the length of the base would be 1 because 9 minus 8 is 1. So the length of our base will always be the distance we extend to the right on the t-axis, whether it be at 11 or 10 or 9 or 12. The length of that base will always be our t value minus 8, because that will always get us the length of the base. So the length of our base will always be t minus 8. And then, of course, that's times 10. But if we want to write this in a little bit more algebraically friendly way, we could say that's the same thing as 10 times t minus 8. So the expression 10 times t minus 8 will get us the area under this part of the curve, no matter how far we extend on the t-axis. Now, the other piece of this puzzle is figuring out the area from 0 to 8, because we'll need to add that area or that displacement to our expression. Well, we already have this because we've already found the displacement from 0 to 2 and from 2 to 8. So to find the total displacement from 0 to 8, we just add those two values together. The displacement from 0 to 2 was 30 meters, and the displacement from 2 to 8 was 105 meters, which gives us a total displacement of 135 meters. So the total area under this curve would be 135 plus 10 times t minus 8. And then we simplify that. That'll give us 135 plus 10t minus 80, which is equal to 10t plus 55. And again, this would be in meters.